Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1659, specifically relates to an issue with the Electronic Throttle Control System, ETCS, relay, indicating a malfunction in the control relay circuit. This code is critically important because the ETCS is responsible for controlling the throttle body electronically, regulating engine power and emissions. In the Honda Civic models from 2011 to 2015, the ETCS relay is located within the under-dash fuse relay box, which is situated beneath the dashboard near the steering column. The functioning of this relay directly impacts the vehicle's performance, and if a malfunction occurs, it can lead to reduced power, increased emissions, or a complete engine shutdown, which can significantly compromise driving safety and performance. Therefore, understanding how to diagnose and address issues related to this DTC is paramount for effective vehicle maintenance and repair. DTC P1659 indicates a failure in the Electronic Throttle Control System, ETCS, control relay, which plays a critical role in managing engine power and throttle response. The ETCS relay is connected to the throttle body and ensures its electronic control module sends appropriate signals. Specifically, the relay is situated in the under-dash fuse relay box, which houses various critical electronic components for managing vehicle operations. When the relay is malfunctioning, it can disrupt the signals affecting the throttle's ability to open smoothly, leading to poor engine response or unintended power loss. Additionally, regular checks on the relay and its connection to the engine control module, ECM, can help in maintaining optimal performance and prevent similar DTC issues in the future. Several factors can contribute to the occurrence of DTC P1659. One of the most common causes is a faulty ETCS control relay itself, which might not function correctly even when not visibly damaged. Another possible cause is a blown fuse, specifically fuse A2215A, which is located in the underhood fuse relay box. If this fuse is not operational, it prevents the relay from receiving the necessary power to operate. Additionally, wiring issues may occur, including open or short circuits within the wiring connected to the ETCS system. These wiring problems can prevent signals from reaching the appropriate circuit points and hinder the proper functioning of the ETCS relay. A thorough inspection of these components can help identify and resolve the root cause of the DTC. When dealing with DTC P1659, several symptoms may manifest, indicating a malfunction within the Electronic Throttle Control System. Notably, drivers may experience reduced engine power or throttle response, making it challenging to accelerate or maintain speed. These issues are often resolved by the ETCS. When it fails, it directly impacts the driving dynamics of the vehicle. Another common symptom is the illumination of the check engine light, alerting the driver to a Diagnostic Trouble Code's presence. This warning serves as a first step for diagnostics, prompting further investigation into the ETCS relay and associated circuits. As such, addressing these symptoms promptly can prevent further complications and enhance overall driving safety. The first troubleshooting step for DTC P1659 involves verifying the problem conditions. Begin by turning the ignition switch to the on position and employing the Honda Diagnostic System, HDS, to clear the DTC. This is crucial because it allows the technician to reset the system and check for any immediate issues. After clearing the code, the next step is to check for any pending or confirmed DTCs. If DTC P1659 comes up again, this indicates a recurring issue which requires further investigation, leading to step 2 of the troubleshooting process. If it does not show, there might be an intermittent failure, prompting a thorough check for poor connections or loose terminals at both the ETCS control relay and the ECM to ensure electrical stability. In Step 2, begin by turning the ignition switch to the lock 0 position. This ensures that all electrical systems are safely powered down before inspections begin. Next, check the fuse A22, rated at 15 amps, which is located within the underhood fuse and relay box. Inspecting this fuse is critical because a blown fuse can prevent power from reaching the ETCS control relay, thereby leading to the issues indicated by DTC P1659. If the fuse appears intact, you will proceed to the next step. However, if it is blown, replace it and reassess the situation, as failing to resolve this can lead to further complications in the vehicle's throttle control system. In Step 3, after confirming that the fuse is intact, the next action is to test the ETCS control relay. This involves removing the relay from its socket in the under-dash fuse relay box. With the relay extracted, conduct a functionality test to determine if it is operationally sound. An effective way to test the relay can include using a multimeter to check for continuity or resistance according to manufacturer specifications. If the relay is found to be faulty during testing, the solution is straightforward. Replace the ETCS control relay. Once replaced, follow the repair verification procedures to ensure that the installation resolves the original DTC P1659 issue. Step 4 requires measuring the voltage across the ETCS control relay while keeping it disconnected. First, turn the ignition switch to the on/2 position. This allows the circuit to become active for voltage testing. Measure the voltage across test points 1 and 2. Test point 1 is the ETCS control relay 4P socket number 3, and test point 2 connects to a solid body ground. If battery voltage is present, the relay circuit is functioning correctly, and you can proceed to Step 5. However, if there is no voltage detected, this indicates a deeper issue that will require you to replace the under-dash fuse/relay box as part of the troubleshooting process. In Step 5, you will be focusing on the +B ETCS line. With the ignition set to on/2 and the ETCS control relay still disconnected, you will measure the voltage again, this time at test points defined for the +B ETCS circuit. Test point 1 will be the ETCS control relay 4P socket number 1, and test point 2 remains connected to body ground. Establishing battery voltage here confirms that the power line associated with the ETCS relay is functional. If your measurements indicate that battery voltage is present, you should advance to Step 7 for further diagnosis. However, if you do not see battery voltage, attend to the wiring and connections leading to the under-dash fuse relay box, as these may require attention. Step 6 focuses on examining the +B ETCS line for any potential interruptions. Start by turning your ignition switch to the lock 0 position. Disconnect the under-dash fuse relay box connector D32P, which allows you to isolate circuits better for accurate testing. Next, measure the voltage between test points. Specifically, you will be testing from the connector D32P, number 12, yellow, to body ground. If voltage is detected, it implies that the +B ETCS wiring is intact, warranting the replacement of the under-dash fuse relay box in the next steps. In contrast, if there is no voltage present, it suggests that an open issue exists along the wiring from fuse A22 to the under-dash fuse box, requiring repairs. For Step 7, the focus narrows to checking the continuity in the VB ETCS and ETCS RLY out circuitry. Power off the ignition switch, jump the SCS line with the HDS, and disconnect the ECM connector C49P. Proceed to check for continuity between specific test points. You will measure from the ECM connector C49P number 1 LT green to the 4P socket number 2 of the ETCS control relay. If continuity is established here, then the wiring for the VB ETCS and ETCS RLY out is functioning correctly. If not, it will be necessary to repair any open connections found between the ECM and the ETCS control relay to restore system function. In Step 8, the process requires you to disconnect ECM connector A, 49P. With ETCS control relay disconnected, you will verify the continuity of the ETCS RLY-CL line. Measure continuity between test points specified from ECM connector A, 49P, number 48, yellow, to the ETCS control relay 4P socket number 4. If continuity is confirmed, the wiring associated with the ETCS RLY-CL line is operational. However, if you do not find continuity, investigate and repair any breaks or malfunctions along the ETCS RLY-CL wire between the ECM and relay, as this issue may be contributing to the P1659 code. Step 9 is aimed at addressing potential shorts within the VB ETCS and ETCS RLY lines. Start by removing the ETCS control relay from the under-hood fuse relay box and jumping the SCS line. Disconnect ECM connector C, 49P, as it needs to be isolated for clarity in testing. Measure continuity from test points from ECM connector C, 49P number 1, yellow, to body ground. If continuity exists, this indicates that a short exists somewhere along the wiring, necessitating repairs. If there is no continuity, this relates to possible issues elsewhere in the VB ETCS and ETCS RLY out circuit, which may also need further investigation. In Step 10, assess the +B ETCS line relative to the engine control module, ECM. Verify the continuity through the circuit by comparing test point 1 at the ETCS control relay 4P socket number 1 to body ground. If continuity is established at these points, it indicates that the +B ETCS line is functioning as expected. If continuity is not present, you may need to consider updating the ECM software or substituting it with a known good ECM, as this could rectify the core issue affecting DTC P1659 during the troubleshooting process. The final step, Step 11, revolves around ensuring the +B ETCS circuitry is free from shorts. Disconnect the under-dash fuse relay box connector D, 32P, to enable effective inspections. Check continuity between test points from the under-dash fuse relay box connector D, 32P, number 12, yellow, to body ground. Establishing continuity confirms that the circuit is intact and operating correctly. If not, a repair of any shorts found within this wiring is necessary. If no shorts exist, the final recommendation may involve updating the ECM software if it's out of date, or substituting the ECM to ensure reliability within the throttle control system operations. After completing the necessary repairs and replacements according to the previous steps, verify all repairs are completed correctly during the final verification. Begin by turning the ignition switch to the lock 0 position and reconnect all previously disconnected connectors. This includes the ETCS control relay and the ECM to ensure that the electrical system is correctly configured for operation. Once reconnected, turn the ignition switch to the on 2 position and utilize the Honda Diagnostic System, HDS, to reset the ECM. This reset is important as it allows the system to recalibrate after repairs. Finally, check for any pending or confirmed DTCs to ensure that DTC P1659 has been resolved. noting that persistent codes may indicate further issues needing attention. Preventive maintenance is crucial to avoiding future instances of DTC P1659. Regularly inspecting the electrical circuits related to the Electronic Throttle Control System prevents minor issues from escalating. Ensuring connections remain clean and free from corrosion will help maintain excellent electrical continuity and reduce the risk of intermittent faults. Furthermore, keeping the engine control module, ECM, software up to date ensures the system benefits from the latest enhancements and bug fixes from the manufacturer. By employing these maintenance practices, you can enhance the longevity and reliability of the vehicle's throttle control system, effectively minimizing troubleshooting events in the future. In conclusion, understanding the role of the electronic throttle control system and its relay is vital for effective diagnostics related to DTC P1659. This code signifies a malfunction in the relay circuit, which can lead to significant driving issues. Following the detailed troubleshooting steps allows technicians to methodically identify the symptoms and causes of the problem. Additionally, implementing regular maintenance checks and keeping the ECM software up to date can further help in preventing future occurrences of this code. By maintaining vigilance in vehicle care, drivers can enjoy a reliable and well-functioning Honda Civic while minimizing disruption related to throttle control issues. Please like and subscribe to the channel. See you next time!